So welcome students. So in this question, you given that one of the vertex of a square is -2, 2. So -2, 2 is one of the vertex of the square, and the square has at least one axis as the axis of symmetry. So the square has at least x-axis or y-axis as the axis of symmetry. So if that is so, how many squares can be formed? That's the question. So first let us assume that x-axis is the axis of symmetry. So if x-axis is the axis of symmetry, so what are the possible squares that can be formed? So if x-axis is the axis of symmetry, obviously if -2, 2 is one vertex, because x-axis is the axis of symmetry, the one of the other vertex has to be -2, -2. Now there are two cases. So if this vertex is the adjacent vertex, you get a square like this, you can get a square like this, or a square like this. You can get two squares. There are two possible squares, for both of which x-axis is the axis of symmetry, and these two points are adjacent points. And if these two points are diagonally opposite points, assume that these two points are diagonally opposite points, then you get another case where the square can look like this. So the square might look like this. So this square is also symmetric about x-axis, but there is only one square for which A and B are the opposite sides. There is no third square. So totally you have three different squares till now, with x-axis as the axis of symmetry. Now if you take y-axis as the axis of symmetry, so if -2, 2 is a point, so 2, 2 should be another point. So if these two are adjacent sides, you can get in the same way as we have done for x-axis, one square like this, or the other square can be like this. So this is also a square with one vertex as -2, 2 and the axis of symmetry as x-axis. So this is a case. Otherwise, so what happens if these two are diagonally opposite points? You can also get a square like this, you can also get a square like this. So this is also a possible option. So till now you get 1, 2, 3, 4, 5 squares. You get 5 squares. Next, is there a square which is symmetric about both axes? So if the axis of symmetry is x-axis, you have three cases. If the axis of symmetry is y-axis, you have three cases, but you have one case in common. Now, is there a square which is symmetric about both the axes with vertex as -2, 2? So that is same as the square that we have drawn earlier. So you won't get an additional square which is symmetric about both axes. So there are a total of 5 squares which satisfy the given conditions. Thank you.